So we actually did learn this in 1010, so it's just another kind of review topic. So 4-5 will be solving logarithmic and exponential equations. Now, we have seen these steps before, so our first step is to isolate the logarithm or exponential base to one side of the equation. So in the blue equation here, we would get base 3 all by itself, and in the red equation, we would get log base 2 all by itself on one side of the equation. So I'd add 1, right? So then I'd have base 3 to the x plus 2 equals 7. And then right here I'd add 1. That would be your first step. Isolate the log base and isolate the base. Alright, second step is to undo the base or logarithm by applying the correct inverse. So just a reminder, we can't divide by 3. That's not what undoes a base 3. What undoes base 3 is log base 3, right? Log base 3 both sides. So log base 3 and base 3 undo each other because that's what inverses do. So we have x plus 2 is equal to, now right now I have this, log to the base 3 of 7. I could not calculate that as is because I would not be able to put that into my calculator. So we just learned last time the change of base formula. So I should be writing that as log of 7 divided by log of 3. And now we would be good to type it into our calculator, which we won't do quite yet. So everybody good with that one? So how do we undo log base 2? Base 2 both sides of the equation. Log base 2 and base 2 cancel out. So we have x plus 2 is equal to, that's not 2 times 5. That is base 2 raised to the 5th power, which is 32. Alright, then from there we're to our third step, which is now that you've undone the base or logarithm, solve for x using correct algebra. So in this case we just subtract 2. So our answer is x is equal to log of 7 divided by log of 3, and then after that we're going to have minus 2. Then you would type that into your calculator and you would get a decimal. So let's everybody do that. And let's round to 2 decimal places. So negative 0.23. Did you get that? Now if we were checking our answer, we would want to write down the entire decimal, and we could go back to the original and plug it in, but you would need the entire decimal. Otherwise, when checking, you're going to be off a little bit. Alright, sweet. So right here we just subtract 2, so x is equal to 30. Now just a reminder, this is really important, and it was hard for some of you to grasp in 1010, because I think instead of actually thinking about it, you just tried to memorize this idea. So think about it so that you can remember it correctly. On the fourth step here, we need to check our answers to make sure we don't have any potentially extraneous solutions. Now everybody listen. Exponentials, I'm going to go back to an exponential equation here. An exponential looks like this. So our domain for exponentials is all real numbers. Therefore, the input can be anything. We can input anything into an exponential. So will an exponential ever have an extraneous solution? No. You can input anything into an exponential. Do you guys see what I'm saying? So you should be able to take your answer and check it. Now logarithms can have extraneous solutions. Because recall, a logarithm has a vertical asymptote at 0 and looks something like this. Our input is not negative or 0 for logarithms, correct? So when you check your answer, what you would do is say, okay, if I take 30 and plug it into my logarithm, will it make it negative inside the logarithm? Because that's input, it's inside. 30 plus 2 is 32. It does not make it negative inside, so it would not be an extraneous solution. Questions on that? Okay, let's practice a couple. Now, a lot of these examples you probably won't even need to write down. I'll tell you the ones that I feel like are hard enough for you to write down. Otherwise, I think you're going to get more out of just watching it and then practicing on the homework. So if I said to you solve, you'd say, well, this is an exponential equation, so I need to isolate the base. So what would I do? Divide by 8. Okay, cool. So we have base e raised to the 2x equals, then the simplified fraction is 5 halves. They both divide by 4, right? What undoes base e? So we'd ln both sides. Ln and e cancel out, so we have 2x is equal to ln of 5 halves. Now question, is ln of 5 halves the same thing as ln of 5 divided by ln of 2? You're correct. No. Some people in first hour said yes. If I really so desired, how could I rewrite that? Oh, yeah, that technically correct, but that's extremely more complicated than I was thinking. But that was not wrong. Not wrong. Guys, we learned properties of logarithms last time. ln of 5 minus ln of 2. Yes, but not necessary because we have an ln button on our calculator. I was just testing you. So divide by 2. So you literally just type in your calculator ln of 5 halves divided by 2. If you don't mind, just give me a decimal to 2 places for my video, please. 0.46. Thank you. Anyone else get that to make sure? Yes. Awesome. Cool. Moving on to the next example. All right. Isolate the exponential. Done. Then you would ln both sides. ln and e undo each other. 3 minus 2x is equal to ln of 4. Then solving for x, what would we do now? Minus 3. Then we would divide by negative 2. So everyone make sure you can type it into your calculator, right? So everybody, once again, for my video, please, if you wouldn't mind getting me a decimal. .81? Cool. Pretty straightforward stuff for the most part until we get to a little bit more advanced ones. Like this one. Now this one still is one that we have seen a couple times this year. Can anyone tell me maybe how to tackle this one? Now keep in mind e to the 2x minus e to the x cannot be put together. They're not like terms. That's like an x squared and an x, right? Can anyone remember maybe what this kind of looks like? What I could maybe do? Yes? Okay, you're on the right track, Dave. You're saying e to the what? Okay, never mind. Not that idea, but that was a good try. Yeah, it technically kind of does. U substitution, isn't this quadratic in form, everybody? 2, 1, constant. That's when we have quadratic in form. What would be my U substitution? E to the x, correct, everybody? Because then we have now u squared minus u minus 6 equals 0. Now we can solve for u. What multiplies to be negative 6 and adds up to be negative 1. 3 times 2, negative 3. So this quick factor is to be u minus 3, u plus 2. Now we could solve, so u equals 3 and u equals negative 2. Agreed? But u is not what we're solving for. We got to put back in e to the x. So we have e to the x equals 3. E to the x equals 3, and we also have e to the x equals negative 2. Now you're trying to solve for x, so how do you undo e? ln both sides. ln and e undo each other, so x is equal to ln of 3. That's our first answer. Decimal to 2 decimal places. Perfect, so 1.09, so we'll go with 1.1. Everybody good with that? Now right here we would ln both sides. If you did try to type that in, you're going to get error because can we ln a negative? No, so that is an answer that is not a solution. So let's throw that answer out. Does everybody see why? ln of negative 2. So our only answer is this ln of 3 of 1.1. Yeah, ln of a negative. That's a log of a negative. Because then we would have e to the 2u minus e to the u, which would not even change the problem at all. It just switches out the variable. Does that make sense? We want it to look quadratic, so it'd be e to the x. Remember, this is obviously, like right here, if this is our x squared, this would be our x, that would be our u. And remember, the second thing's always the u. Okay, good question. Okay, next one. This is another one I would recommend writing down, because it is a little different. 3x e to the x plus x squared e to the x equals 0. Now this one's not quadratic in form, in a way. So we're trying to solve this. So any ideas of where we might start? Yeah, why? That's a great idea. Now let's factor something out. What would you suggest? Okay, we can factor out e to the x. Sure, let's factor out the greatest common factor. So let's see if that helps us at all. Let's pull out x e to the x. And then let's see what's left in our parentheses. So go back and divide x e to the x to both pieces. And like write down what's left over in each term. So notice the x's divide out, the e to the x's divide out. So in my first term, a 3 is all that's left. We have x squared divided by x. So we have a plus x, don't we? And e to the x's divide out. Now if we have something factored down to linear factors, can't we set each of the factors equal to 0 and solve? So now keep in mind, guys, these are separate factors. People get stuck right here because they think those are stuck together, but they're not. They're separate factors. Does everybody see it? We have 3 factors here. Set each of those equal to 0 and solve. X equals 0, e to the x equals 0, and 3 plus x equals 0. Now we're going to solve for x in each of these cases. So x equals 0 is already solved for, isn't it? There's one of our solutions. Then right here, trying to get x alone. ln both sides. Now let's try typing it into your calculator. It says you can't. Can anyone tell me why? Yes? So elaborate what you mean. On the domain, you're saying the domain can't be 0, but why? Good. Asymptote. Logarithms have asymptotes on 0, meaning we can't plug in 0 or negatives, right? Way to think. So this one's a solution we throw out. Solve for x here. X equals -3. Now I had someone in first hour say, well, we can't have negatives. Not true. Look at the original problem. Is it even a logarithm? No, we can plug in negatives into non-logarithmic equations, right, everybody? So this is not, we didn't have a logarithm of a negative ever come up. All right, perfect. We had 2 solutions in this case. All right. So another couple of easier examples, which I don't think you need to take notes on, and I'll tell you which ones I do think you need to. Because in this one, just solve for x. First step is to add 4, so we have 2 ln of x equals 10, then. So ln of x equals 5, then e both sides. X is equal to e to the 5th power, and you would just type it into your calculator. Let's just go 2 decimals again to be quick and efficient. 148.4. Now we did start with a logarithmic equation, so I'm going to go see if I plug in that value, if it would make it negative or 0 inside the log, would it? No, so it's not extraneous, right, everybody? There would be no solution because there was only one, so we just throw it out and say no solution. Okay, another one. So tell me what I do. Base 2 both sides. Isn't that what undoes a log base 2? So we have 25 minus x equals, that's not 2 times 3. Don't be that person. 2 to the 3rd power is 2 times 2 times 2, which is 8. Then we'll subtract 25. So now, oh, that's a 25, sorry. And we have negative x equals negative 17. Therefore, x equals 17. Then you'd say, well, I started with a logarithmic equation, so I need to go see if I plug in my solution, if it would make it negative or 0 inside my log. Would it? No? No, right? 25 minus 17 is positive, so we're not in trouble. Okay, so our solution is 17. Okay, another one. Minus 4, then we would divide by 3. So we have log of 2x equals, that was 12 divided by 3, which is 4. Then what? Base 10 both sides. Way to remember, log of nothing is secretly base 10. So we have 2x equals 10,000. Then divide by 2. So x is equal to 5,000. We started with the logarithmic equation. If I plug in 5,000, will it make it negative or 0? No. All is good then. What is he saying back there? Oh, it's snowing. Yeah, I know. Sucks. Okay, now looking at this one, log of x plus 2 plus log of x plus 1 equals 1. I always have people do some weird stuff here. Now, one thing I see people do is they go, well, I'm going to base 10, base 10, base 10, and as long as I do it to the whole thing, I'm all good here. Wrong-o, wrong-o, okay? This is a plus sign. You just base 10 across a plus sign, which is equivalent to doing like a squared across a plus sign. You can't do it. So we need there to be 1 log base 10. How can we put this together? Yep, properties Dave, you're saying because you add, you multiply. So this is actually log of parentheses x plus 2 times x minus 1. And that's equal to 1. And now it would be appropriate, since you only have one logarithm and you're not doing it across an addition sign, to base 10 both sides. So let's look at what we have here. We have our x plus 2 times x minus 1 equals 10 to the first, which is 10. When solving something of this caliber, don't we usually have quadratic set equal to 0? Well, we have a quadratic set equal to 10. We can't solve this as is. So we actually have to put it back in standard form, get it equal to 0, and then solve. So if I was to distribute and combine like terms, what I'm going to get is x squared plus x minus 2 equals 10. So subtract 10. X squared plus x minus 12 equals 0. Now I can factor it and solve. What multiplies to be negative 12 and adds up to be 1. 4 times 3, which one's negative? 3. So this factors to be x plus 4. X minus 3. So my two solutions. X equals negative 4 and x equals 3. Then you'd say, I started with a logarithmic equation. I need to check to see if I plug in either of those, if it'll be negative inside a log. If I plug in negative 4 right there, or right there, does it make either of those negative inside a log? Yes, therefore it's not a solution. We cross it out. If I plug in 3, is it positive inside? Yes, that's 5, that's 2. So the only solution is 3. Okay, another one, because a lot of people think that it's always going to be all negatives are extraneous solutions, which is not true. Here's a perfect example. So we would do what? Base 2 both sides. So then my true statement is this. X squared minus x minus 2 equals 4. We're solving a quadratic, so we get it set equal to 0. X squared minus x minus 6 equals 0. Well, multiplies to be negative 6 and adds up to be negative 1. 3 times 2, negative 3. A quick factors to be x minus 3, x plus 2. Therefore, solutions are x equals 3 and x equals negative 2. Now, don't just say, well, I can't plug in a negative into a logarithm. That's not true. That's not what the true statement is. The true statement is, if I plug in, will it be a negative inside? So let's test it out. If we plug in 3, that would be inside our parentheses, 3 squared minus 3 minus 2. 9 minus 6 is 3, yeah? It was positive inside when I plugged in 3. Let's plug in negative 2. Negative 2 squared minus negative 2 minus 2. 4 plus 2 minus 2 is 4. Is 4 negative? No. Therefore, negative 2 is also a solution because it didn't make it negative inside. So make sure you don't misunderstand that idea. All right, doing good. We're actually flying through this lesson. You guys are awesome. Okay, another one. Can I have base 5, base 5, base 5? Nope. But what could I do? So log base 5 of, good, when you add, you multiply. So then that's equal to log base 5 of 20. Now I had someone first hour say to me, could I subtract that over and then divide? Yes, but you're just making your life a little bit harder than necessary. The math would work out the same, and a lot of people that do that end up making an error. So just leave it a log base 5 on both sides, because can't I base 5 both sides? So my true statement is x times x plus 1 equals 20. To solve a quadratic, I would get it in standard form. And solve by factoring. What multiplies to be negative 20 adds up to be 1. 5 times 4, negative 4. X plus 5, x minus 4. X equals negative 5, x equals 4. Would either of those be extraneous? Negative 5. If I plug in negative 5, it would be negative inside a logarithm. Therefore, it's extraneous. So I'd only circle 4. Everybody understanding? Okay, doing good. All right. No, if you plug in negative 5 right here, it's going to be a negative inside a log. Okay.
Is it like for get the test each one?
Yeah, I mean, but if it happens anywhere, then you just can move on because it can't be negative anywhere inside a log, if that makes sense. So if it worked here but not here, still problem. If it worked here, not, you know what I mean? Any negatives mean throw it out inside a log. Okay, I want you to try this one all by your little self. Try it. When you think you've got an answer, let me know.
You want to like put it in a
Okay.
What? If x equals
Okay, let me get started. Okay, x equals,
log of negative third. Oh, and then over log of 1/4.
okay.
And then just plus 2. Oh wait, sorry. Plus, I thought plus 3 something. Yeah. Okay.
Okay.
But it can't be negative.
True. So your answer is no solution. You can't do log of a negative, right, everybody? Okay, awesome. Okay, so another one like that is like this. People just get thrown off by this fractional base, but you guys, it's really, don't get freaked out. Watch, it's really this. Isaac was able to just do it, so I just want to make sure though. So we have base 4 raised to the 1/3 power, 3x minus 1 equals 8. Then we would divide by 4 first, wouldn't we? Don't be the person that log bases at that point, because we got to get rid of the 4. So we have base 1/3 raised to the 3x minus 1 equals 2. And then from here, guys, just because it's a fractional base doesn't change the math. You're log base 1/3ing both sides. Log base 1/3ing. So then we have 3x minus 1 equals, and that would take the change of base formula. That's log of 2 divided by log of 1/3. Then after that, we'd add 1. Then we would divide all of it by 3. And that would get x alone. Don't let fractional bases throw anyone off. That's why I wanted to do that example. So then from there in your calculator, how I would do it is I'd do log of 2 divided by log of 1/3. I'd hit enter. Then I'd add 1, hit enter, then divide by 3. All right. This one you need to all write down. I added this example in after first hour. Could not do this type of problem in the homework. We have base 3 raised to the x plus 1 is equal to base 2 raised to the x. Now in this one, there's 2 bases. That's where people get stuck. So everybody, here's what you're going to do. You're going to choose to undo base 3 or base 2. Now you do have to do it to both sides of the equation. Here's what I suggest. Always undo the base. Now it would be right either way, but always undo the base with the uglier or larger exponent. So the uglier exponent technically is x plus 1. Agreed? So let's undo base 3. So we would log base 3 both sides. Log base 3 and base 3 cancel out. So on the left it actually is nice. We have x plus 1 is equal to, now we have this. Log base 3 of 2 raised to the x power. But that's not a power and a power, is it? It's just a base raised to a power. Now, didn't we learn, though, that...
Why is it the x inside the parentheses? Like, why is it 2 to the x?
Oh, same thing as
It's the same thing.
2 to the x.
Oh.
Good question. Because other people were probably wondering that same thing. They are the same thing, everybody. Okay, so from here, guys, normally, if we didn't have x, we could do change of base formula no problemo, correct? But because of the x, we've got to first take care of that. So this is what you're going to do. You're going to take the x and bring it down in front with properties of logarithms. It allows us to do that. They're equivalent statements. So now I have this. X plus 1 is equal to x log to the base 3 of 2. So you're saying that you would prefer to write this as x plus 1 is equal to x and then log of 2 divided by log of 3? Yeah. Okay, good. Now you have to keep your goal in mind. Aren't we trying to solve for x? Yes.
Oh, I know, but it's next. Sorry, yeah. Can't use divide the x.
Dave, you're making a great point. You're saying do what with this? Calculate it. That's just a number, just like 7 is a number. Yeah, okay, Dave, will you go ahead and calculate that for me? Now, if you do it that way, you've got to use the entire decimal, everybody. So we have this, x plus 1 is equal to what x? What x? So everybody here, they're calculating this so that they're just using a whole number. I mean, not a whole number, but. No, I want, if you're going to do it this way, you've got to write down the entire decimal. So what x? Okay, how do you combine x's together then? Guys, how do I solve this? X is equal to, oh, sorry. No. Hey, you're not thinking correctly about this. X plus 1 equals 7x. How do you put the x's together? Subtract x, don't ya? Minus x, so that would be 1 is equal to 6x. Yeah. Same thing here, just because it's a decimal doesn't change the math. So how do we combine a decimal with a number? Just subtract it over. So do you want to take this over that way? Subtract x from both sides. So I have a true statement now. 1 is equal to what x? So how would you do that in your calculator? 0.6309297536 minus 1. Aren't you just combining like terms, everyone? So we have 1 is equal to, you're just combining like terms. That's an x, you're putting them together. 0.63092756 minus 1. I need the entire decimal. Negative point. Okay, now get x alone. Divide it out. Okay, there you go. And now x is alone. So now x is equal to, now we can round because you can only round in your final answer. Does that kind of make sense to everybody? Okay. 1 divided by negative 0.360907.025. I get negative 2.77. Okay, awesome. Okay, awesome. Okay, let's look at these quick 2-story problems and then our examples are over with. So the story problems are going to be pretty straightforward for the most part. It is going to be plug and chug, but you do have to pay attention to where you're plugging stuff in. So it says if I sub 0 and I denote intensity of light before and after going through a material, and x is the distance in feet that the light travels in the material, then according to the Beer-Lambert law, this is our formula, where k is the constant depending on the type of material. So in part A it says solve the equation for I. So we need to get I alone. So let's use correct algebra in the most simplified form to get I alone. So what should I do? My first step to get I alone is to get rid of the negative 1 over k thing. Yes. How would we get rid of negative 1 over k? Okay, times k over. Should we hit 2 birds with 1 stone and get rid of our negative as well? You guys see what he's saying, times by k? People said first hour divide by 1 over k, but then you have to flip and multiply. So isn't it smarter to times both sides by k? And let's get rid of the negative, so we'll times both sides by negative k. Times by negative k. So then we'd rewrite, look, negative k times negative 1 over k is 1. So now we have this, ln of I over I sub 0 is equal to a negative k times x is negative xk. Next step to get I all by itself is to get rid of ln, so we would e both sides. So now I have this, I over I sub 0 is equal to e raised to the negative xk. Then what? Multiply by I sub 0. So we have I is equal to I sub 0 e to the negative xk. Now we solve for I. Part B, it says, for a certain length k that's equal to 0.025 and the light intensity I sub 0 is 14 lumens, find the light intensity at a depth of 20 feet. So now part A set us up to be able to solve very easily for I. It's just now plug and chug. So I is equal to, our I sub 0 is 14, E is E. We have a negative x, wasn't x the depth, it said? Okay, yep, perfect. Distance or depth in feet, so negative 20, and then times by the k. The k in this one was 0.025. And now you can just type it into your calculator, and we get, I think, 8, if you wouldn't mind typing it in, because I think I remember we got 8.5 or something, 8.6. 8.5. The story problems aren't asking anything different, just in a different way. Okay, let's read this one, because we do need to remember our interest formulas. There's 2 of them, if you can recall, from the last exam. So, I don't know. You can't count on it, though. So that's why I just would have you make sure you memorize it. The sum of $5,000 is invested at an interest rate of 5% per year. Find the time required for the money to double if the interest is compounded semi-annually and continuously. So there were 2 different... Sorry. There were 2 different formulas. For compounding continuously, it was y is equal to p times e raised to the rt. Agreed? For compounding more than once a year or a certain number of times a year, it was y is equal to p times 1 plus r over n raised to the nt. So we're just going to be doing a plug and chug and then solving for what we need to know. So it says the sum of $5,000 is invested at an interest rate of 5% per year. So isn't the put down amount in this particular problem 5,000? So right here is 5,000. Then we have our 1 plus our interest rate was 0.05. Then since it was semi-annually, n is the number of times a year, so wouldn't that be 2? Raised to the 2t. Doesn't it say how much time? Now what? We don't even have an equation. Equals what? They want the money to be double. Therefore, in the end, we would have 10,000. Okay. Now, all we have to do, you guys, is solve for t. So, first step to get t alone. Divide by 5,000. So, we have 2 is equal to. Now, if you actually calculate that, you get 1.025 raised to the 2t. So we're trying to get t alone. Next step would be to get rid of the base. Good. Log base 1.025 both sides. Log base 1.025. So on this side, I need to change your base formula, which would be log of 2. Divided by log of 1.025. And that's equal to 2t now, isn't it? Just did that and that is equal to 2t. So then we'll divide by 2 to get t alone. So to get our $5,000 to double, we're going to have this money in the account for how many years? $14 years. 14.03 years. Okay, let's do the compounding continuously. How much in the end? 10,000, right? Isn't it the doubling? Our put down amount was 5,000. E is E. Our interest rate was 0.05 and T is the time we're trying to solve for. So get T alone. Wouldn't we divide by 5,000? Trying to get T alone, you would divide by 5,000. 2 is equal to base E raised to the 0.05T. Next step. You guys, we're just trying to solve for T. ln both sides. So ln of 2 is equal to 0.05T. So then divide by 0.05. Divide by 0.05. And then T is alone. $13.86 years. OT. So T is equal to 13.86 years. Okay, awesome. That is the end of the lesson. The rest of the time is yours. You should be able to get a good chunk of the homework done.